Hello guys, and welcome back to my YouTube channel. In this video, we are going to solve a question under composition of functions and injectivity of functions and injective functions. So let us start. In this question, we have been given g of x, we have been given g of f of x, and we know that g of f of x is a composite function. So here is just a normal function. So we have been told to find f of x and show that f of x is injective. Okay guys, here is what we are going to do. We know g of x. We have been given g of f of x. Normally, how do we normally find g of f of x? How do we normally find g of f of x? Here we substitute f of x. We substitute x in the g of x function with f of x. So here normally we were going to take, if we were given the f of x function, we are going to take the function and substitute it with this x. But we have not been given the f of x function, sorry. So we are going to substitute f of x manually. So we are going to have g of f of x, sorry, let me just cancel this. We are going to have g of f of x equal to, remember I'm breaking it down, we know f of x, we need to, if f of x was given, to find g of f, we would just break it down. We know f of x, then we would take the results and substitute it with x in the g of x function. But here we are going to substitute the f of x in the g of x function like that. So our g of x is x plus 5. So we are going to take this f of x and substitute it with x in the g of x function. So we are going to have f of x plus 5. This is what we are going to have. Okay, let me just erase this. Let me do this again. Let me just put f plus 5 to make it a certain variable that we don't know. So let's just say f, since if I add the x, it might confuse us in the continuation. So we have f plus 5. This is our g of f of x. But we have been given g of f of x. We have been given the function. So we are just going to equate this with this, since they are basically the same. So we are going to have f plus 5 equal to 6 into x minus 3 on x minus 4. So this is what we are going to have. So now we are going to make f the subject of the formula. Since we are looking for f of x, I've just put it as f. Since we are looking for it, we will make it the subject of the formula. If we were looking for x, we would make x the subject of the formula. But here we are looking for f of x. So we simply make it the subject of the formula. But first, let me simplify this. So we have f plus 5 equal to 6x minus 18 divided by x minus 4. So that is what we have. Plus, okay, so we will send this 5 this way now. That is what we're going to do. So we will have f equal to 6x minus 18 on x minus 4 minus 5. Okay, so looking at this, what can we do? we need to simplify this right now. We need to simplify this. We cannot leave it like that. We cannot just say f is equal to this. We need to simplify it. If it can be simplified, then we go ahead and simplify it. So we will have 6x minus 18 on x minus 4 minus 5 on 1. So now we look for the LCM. We take the LCM, which is x minus 4. So there we are going to have 6x minus 18 minus 5 into x minus 4. Yes, that is what it is going to be. So we are going to simplify it further. We will have 6x minus 18 minus 5x plus 20 divided by x minus 4. I just did a simple simplification. So here I opened this bracket. This is 6x minus 18. No, sorry, let me just start from this. So here we are taking the LCM. The LCM is x minus 4. I opened this bracket. This is 6x minus 18 here. So we'll take minus 5 times x. Minus 5 times x is minus 5x. And here we had minus 5 times minus 4. So minus and minus is going to give us positive. And 5 times 4 is definitely 20. All that divided by x minus 4. Okay, so let me simplify it further. So what is 6x minus 5x? 6x minus 5x is just simply x. It is 1x. So we have x, and then minus 18 plus 20 is 2. It's positive 2. So we have x plus 2 divided by x minus 4. Okay, let's check it out. Can it be simplified further? I don't think so. No, it cannot. So then we conclude f of x is equal to x plus 2 divided by x minus 4. So this is what we have. And if we want to state the domain, we are just going to say where x is an element of R and x is not equal to 4. Not equal to 4, because if you place 4, if you substitute x here by 4, we are going to have 4 minus 4, which will give us 0 and make the equation undefined. So this will be our domain. I'm just stating it, to just show you guys, to remind you guys. Okay, so that is what we will have. Okay, that is our f of x. But that is not all. The question told us to find f of x and show that it is injective. So let's go. Remember, for injectivity, remember it is f of x1 should be equal to f of x2, which is x1 should be equal to x2. So when you substitute this, when you substitute x1 into this equation, and we substitute x2 into this, and when we equate them, at the end we should have x1 equal to x2. That should be our final answer to show that it is injective. Okay, let's go. So let's take the first case. F of x1 is equal to x1 plus 2 divided by x2. Sorry, this is x1. We're still in the x1. Divided by x1 minus 4. And our f of x2 is, we just substitute x2 into our f of x equation, x2 plus 2 divided by x2 minus 4. So we need to equate them and see if we are going to end up with x1 equal to x2. So let's go. x1 plus 2 divided by x1 minus 4 equal to x2 plus 2 divided by x2 minus 4. So let us cross multiply. Let's cross multiply. We are going to have x1 minus 4 times x2 plus 2. I'm taking this and this first, equal to x1 plus 2 multiplied by x2 minus 4. Okay, so now let's open the bracket. We have x1 times x2, that is x1, x2, x1 times 2, that's plus 2x1, minus 4 times x2, minus 4x2, and then minus 4 times 2, minus 8, equal to, we open this other bracket, x1 times x2, x1, x2, x1 times minus 4, minus 4x1, 2 times x2, that's plus 2x2, and then 2 times minus 4 still gives us minus 8. So here we go. Okay, if we observe closely, we have x1 and x2 here. We have x1 and x2 here. If this crosses over, its sign will change, because initially here it has a positive sign, so its sign will change and we will have x1 x2 minus x1 x2. So let me show you guys what I'm talking about. So if we cross this here, and we also have minus 8 and minus 8, so we also cross it over, we are going to have x1 x2 minus x1 x2, this is what we crossed over, plus 2x1 minus 4x2 equal to minus 4x1 plus 2x2. Oh, sorry, I omitted 8 here, sorry. This x2, and oh gosh, I did. So let me just erase this. So we have a minus 8, and then this is a negative. When it crosses over, its sign changes to positive 8, now equal to minus 4x1 plus 2x2. Okay, as we see clearly, x1 x2 minus x1 x2, this gives us 0, minus x plus minus 8 plus 8, this gives us 0 2. So we are left with 2x1 minus 4x2 equal to minus 4x1 plus 2x2. Okay, this is what we have again. So we are going to bring like terms together. So as we can see, we have x1 and x2. So we will take the terms of x1 to one side and the terms of x2 to the other side. Okay, let's have it. 2x1 plus 4x1. We send this way and we send this way. Equal to 2x2 plus 4x2. This is what we have now. So what do we do here? We can factor out x1, that is x1, and we'll be left with 2 plus 4, right? Equal to, here we factor out x2 into 2 plus 4 again. So what's 2 plus 4? That is 6. So let's simplify. 6x1 equal to 6x2. What do we do here? We divide both sides by 6. They'll cancel out everywhere. And what do we have right now? We end up with x1 equal to x2. Okay, so remember we wanted to end up with x1 equal to x2, and guess what? That is what we have. So from here we can conclude. We say, therefore, f of x is definitely injective. It is injective. So this is very easy, very simple, very straightforward. Okay, so here we had to find f of x. Remember, we just put f of x in the g of x function and equated it to the g of f of x function we were given. So we just substituted it and we had to find f. We had to make f the subject of the formula to find its function, and this was what we ended up with. And then we had to show that it is injective. We had to determine whether it was injective, and for injectivity, f of x1 should be equal to f of x2, which is the same as x1 equal to x2. So this is what we had to end up with, and as we can see, that was our end point, and which proved its injectivity. So that is it for the question. That's all for today, guys. Thank you for watching this video, and I'll see you guys in my next video.